Hey everyone, welcome back to quantprof. Today, we are going to solve a 2 sigma quant interview problem. Check the description for more quant interview resources. Let's look at the problem. We have an 8x8 grid. We randomly fill each cell of the grid with either a black or white marble, each having an equal probability of 1 by 2. We are interested in the number of white marbles in each row and column. Since each cell is randomly filled with either a black or white marble, the number of white marbles in each row and column will vary. The problem asks, what is the probability that the number of white marbles in every row and every column is even? Pause the video here if you want to give it a try. First, let's calculate the total number of configurations. Each cell in the grid can be filled with either a white or black marble, giving 2 possible choices per cell. With a total of 64 cells, the total number of configurations for the entire grid is 2 raised to the power 64. Now let's calculate the number of configurations where the number of white marbles in every row and every column is even. Let's randomly fill the first 7 rows and the first 7 columns. Now consider the first row. The current number of white marbles in this row is odd. We can make it even by placing a white marble in the last column. Similarly, for the second row, the number of white marbles is even. We can keep it even by placing a black marble in the last column. By following the same approach, we can make the number of white marbles even in the first 7 rows and the first 7 columns. Now, let's name this region as the green region, this region as the blue region, and this region as the red region. If the number of white marbles in the blue region and the number of white marbles in the red region are both odd, we can place a white marble in the bottom right cell, and the last row and column will have even white marbles. Similarly, if the number of white marbles in the blue region and the number of white marbles in the red region are both even, we can place a black marble in the bottom right cell, and the last row and column will still have even white marbles. For example, in the current configuration, we can place a black marble at the corner. But what if the number of white marbles in the red and blue regions have different parities? What if one is odd and the other is even? We will not be able to make the number of white marbles even in both the last row and the last column simultaneously. Fortunately, this case cannot occur. Let's prove it. Consider the green and blue regions. They form the first 7 rows of the grid, and each of these rows contains an even number of white marbles. Therefore, the total number of white marbles in these 2 regions is even. Similarly, consider the green and red regions. The total number of white marbles in these 2 regions is also even. Subtracting these 2 equations, we see that the number of white marbles in the blue region minus the number of white marbles in the red region must be even. Therefore, both must either be odd or even. Otherwise, the difference will not be even. So, for any configuration of marbles in the green region, there is a unique grid configuration where every row and column contains an even number of white marbles. There are 49 cells in the green region, so the number of configurations in the green region is 2 raised to the power 49. Hence, the number of grid configurations where every row and column contains an even number of white marbles is also 2 raised to the power 49. Hence, the required probability is number of desired configurations divided by the total number of configurations, which is equal to 1 over 2 raised to the power 15. Let's consider another problem. A fair 6-sided die is rolled until a 6 appears. What is the probability that the sum of all rolled numbers is even? Try to solve this on your own. If you are serious about excelling at your quant interviews, we invite you to check out our course Quant Interview Masterclass. We cover the entire theory and 1,000+ problems, including company-specific problems from recent interviews. Thanks for watching. See you next time. Until then, Godspeed.